Imagine a world born from the chaos of a stellar nursery, a world that felt the warmth of a star's embrace for only a fleeting cosmic moment, before being violently ejected into the cold, black vacuum between galaxies. No sunrise, no sunset, just an eternal twilight illuminated by the faint, distant glow of countless stars, none of which call it home. These aren't hypothetical worlds from science fiction, they are a profound and unsettling reality. Billions, perhaps even trillions, of these rogue planets drift through the interstellar void, silent and unseen, a testament to the universe's capacity for both creation and abandonment. For millennia, humanity has looked up at the night sky and understood planets as companions to stars, bound in an eternal dance of gravity. Our own Earth, nestled comfortably within the Sun's habitable zone, is a prime example. But what if this isn't the only story? What if countless worlds, some potentially larger than Jupiter, others mere rocky pebbles, were never gravitationally bound to a star, or were ripped from their stellar parents and cast into the ultimate wilderness? These are rogue planets, and their existence profoundly reshapes our understanding of planetary formation, the prevalence of life, and the sheer, breathtaking loneliness of the cosmos. Their story is one of cosmic eviction, a silent exodus into the ultimate unknown. The birth of a star system is a chaotic, violent event. Within swirling disks of gas and dust, called protoplanetary disks, gravity pulls matter together, forming asteroids, then planetesimals, and finally, planets. But this process is far from gentle. Young planetary systems are like cosmic mosh pits, with nascent worlds jostling, colliding, and exerting immense gravitational forces on one another. Imagine a dozen billiard balls all crashing around a table, some getting flung off completely. This is precisely how many rogue planets are born. A close encounter with a more massive gas giant, or the combined gravitational tugs from multiple developing planets, can impart enough kinetic energy to a smaller world to slingshot it out of its home system entirely. It's a violent expulsion, a final, unceremonious shove into the cold, dark embrace of interstellar space, never to return. These aren't just one-off events. Simulations suggest that a significant fraction of planets born in these chaotic nurseries are eventually ejected. Quantifying the number of rogue planets is an immense challenge. By their very nature, they are incredibly difficult to detect, they don't emit their own light, and they don't orbit a star whose dimming we can observe. However, astronomers are getting clever. One primary method involves gravitational microlensing. When a massive object, like a rogue planet, passes directly in front of a more distant background star, its gravity acts like a lens, temporarily magnifying the star's light. These events are rare and fleeting, but by meticulously monitoring millions of stars, telescopes like the Kepler Space Telescope and upcoming missions like Nancy Grace Roman Space Telescope can detect these subtle distortions. Early estimates, based on these observations, are staggering. Some studies suggest there could be at least as many rogue planets as there are stars in the Milky Way, meaning hundreds of billions. Other, more recent models push this number even higher, suggesting there could be 100,000 times more rogue planets than stars, meaning trillions upon trillions of these solitary worlds drifting through our galaxy alone. Without a star, the surface of a rogue planet would be an alien landscape of perpetual twilight. Temperatures would plummet to hundreds of degrees below zero, plunging into the cryogenic depths of interstellar space. The concept of day and night would be meaningless. Any light would come from the incredibly faint, combined glow of distant galaxies and the residual heat from the planet's own formation. Yet, even in this extreme environment, the possibility of life isn't entirely extinguished. If a rogue planet is massive enough, it could retain a thick atmosphere, acting as an insulating blanket. More intriguingly, planets with subsurface oceans, heated by geothermal activity from a molten core, could provide a haven for extremophile life. Think of Europa or Enceladus, moons in our own solar system with vast, liquid water oceans beneath icy shells, kept warm by tidal forces. A rogue planet could sustain similar conditions, its internal heat providing the energy needed for chemosynthetic life, completely independent of a star. Life, if it exists there, would be an isolated, subterranean marvel, never having seen a sunrise. While rogue planets are often depicted as eternally lost, the universe is a dynamic place.
their lonely journeys aren't necessarily endless.
As they drift through the galaxy, they might, on exceedingly rare occasions, have close encounters with other star systems.
Imagine a rogue planet, traveling for billions of years, suddenly crossing paths with a star.
If the trajectory and speed are just right, the star's gravity could capture it, drawing it into a new, albeit highly eccentric, orbit. This second chance at stellar companionship would be a momentous event, turning a wanderer into a denizen of a new solar system.
Conversely, a rogue planet could also be the agent of disruption, plowing through a stable star system and ejecting one of its existing planets.
The cosmos is a grand, unpredictable game of cosmic pinball, where the fates of worlds are constantly being reshaped by the unseen forces of gravity. The concept of rogue planets isn't confined to our own Milky Way.
Every galaxy, in its own chaotic formation and evolution, likely ejects planets into its own interstellar medium. But what about beyond that?
As galaxies collide and merge, the immense gravitational forces involved are capable of flinging stars, and by extension, their planetary systems or even individual rogue planets, out of their galactic homes entirely.
These intergalactic rogue planets would be the ultimate nomads, drifting through the vast, empty cosmic voids between galaxies, perhaps never encountering another star or galaxy for eons.
Their surfaces would be truly dark, lit only by the faint, diffused glow of the cosmic microwave background radiation, the leftover heat from the Big Bang itself. These are truly the loneliest objects in the universe, silent witnesses to billions of years of cosmic history, their journey a testament to the sheer scale and indifference of the universe.
The existence of rogue planets forces us to confront a universe far more diverse and unpredictable than we once imagined. They are not merely anomalies, they are a fundamental component of the cosmos, outnumbering stars by orders of magnitude.
Their frigid, starless existence challenges our assumptions about where and how life might arise, pushing us to consider new frontiers for habitability. They are silent wanderers, ghosts of stellar nurseries, a stark reminder of the immense forces that shape the universe, capable of both creating breathtaking beauty and casting worlds into eternal solitude. As we continue to refine our methods of detection and observation, these lonely worlds will undoubtedly reveal more profound secrets about the universe's past, present, and the unimaginable breadth of its possibilities.
Subscribe for more cosmic deep dives.